Hello everyone, welcome to ThinkComputer YouTube channel. In this video, I will explain about number system, conversion between different number systems, and about binary addition and subtraction. So what is a number system? Number system is basically a way of representing numbers. There are four types of number system. First is called decimal number system. Second is called binary number system. Third is called octal number system, and the last one is called hexadecimal number system. Decimal number system, in this system we have total 10 digits. So it is from 0 to 9. The base of this number system is 10. In binary number system we have only two digits, 0 and 1. So the base of this number system is 2. In octal we have total 8 digits, that is from 0 to 7. So the base of this number system is 8. And in hexadecimal we have total 16 digits, that is from 0 to 15. But we write from 0 to 9 as number, and then instead of writing 10 we write A, instead of 11 we write B, instead of 12 we write C, in place of 13 it is D, 14 is E, and 15 is F. This is written in this way so that to avoid confusion between 10 and 10. For example, if suppose instead of writing A we write 10, then 10 can also be misinterpreted as 1 and 0. Similarly, B is for 11. So if we write 11 in place of B, it can be misinterpreted as 1, 1, right? So that is why we have 10, 11, 12, 13, 14 and 15 represented as A, B, C, D, E, F. So we will start with the conversion, the most basic conversion, that is from decimal to binary. So the first question that I am going to take is 75. 75 base 10 convert into base 2. Base 10, as we know, is for decimal and base 2 is for binary. The rule is to divide the number by 2 repeatedly. Normally when we divide, we write the quotient at the right side or at the top and we write the remainder at the bottom. But now what we will do, we will be writing the remainder on the right hand side and we will be writing the quotient at the bottom. So 2 3s are 6, 7 minus 6 will be 1. 1 and a 5 is 15. So 2 7s are 14, remainder 1. Directly if I say 2 37s are 74. 75 minus 74, remainder is 1. Again 2 18s are 36, remainder 1. Again 2 9s are 18, remainder 0. Then 2 4s are 8, remainder 1. Then 2 2s are 4, remainder 0. Then 2 1s are 2, remainder 0. And finally we can say that 2 zeros are 0, remainder 1. Now this answer will be written bottom to top. So the converted value that is coming up is 100 1011 base 2. This is the binary equivalent of the number 75. Let's take one more question. Suppose the number is 105. 105 base 10 into base 2, that is decimal to binary. So divide 105 by 2 repeatedly. So 2 52s are 104, remainder 1. Then 2 26s are 52, remainder 0. 2 13s are 26, remainder 0. 2 6s are 12, remainder 1. 2 3s are 6, remainder 0. 2 1s are 2, remainder 1. And finally 2 zeros are 0, remainder 1. And write it bottom to top. So the converted value is 110 1001 base 2. Now let us try to convert decimal to binary for real numbers. So first need to understand what is a real number. Well, real number means any number in which there is an integral part and there is a fractional part. For example, if I say 22.525, this is an example. So in this number 22, the first part which is before the point is called the integral part, and 0.525 which is after the point, obviously, that is called the fractional part. So what if we have a real number which is in decimal form, for example like this number, and we have to convert this to binary. So let us see how to convert real numbers from decimal to binary. So we take a question here, that is 50.20. That's a decimal number, base 10, convert it to binary. So we have to solve the integral part separately and the fractional part separately. In the integral part we have 50. So divide 50 by 2. Just like before, 2 25s are 0. 2 25s are 50, remainder 0. 2 12s are 24, remainder 1. 2 6s are 12, remainder 0. 2 3s are 6, remainder 0. And further going down, 2 1s are 2, remainder 1. 2 0s are 0, remainder 1, bottom to top. So the answer comes up 110010. That is only for the integral part. Okay, this is the integral part. For the fractional part, the number is 0.20. So we can simply write 0.20. For the fractional part, we will multiply with 2. So instead of dividing by 2, now multiply with 2. 0.20 into 2, 0.40. Now in this result, the 0 which is there before the point, that we will take out. Then comes 0.40, means bring down the same number here. 0.40 into 2, 0.80. Again 0 will come out. Again write 0.80 into 2, that is 1.60. Now in this 1.60, take out the 1. What is left? 0.60. Okay, into 2, 1.20. In this 1.20, take out the 1. What is left? 0.20. So 0.20 into 2, 0.40, and it comes out 0. So no need to go any further now. For the fractional part, you can stop after 5 steps. So for the fractional, we will be writing the result top to bottom. Okay, top to bottom. So that is 00110 base 2. So the final number that is coming up is 110010.00110 base 2. That is the binary equivalent of 50.20. Let us see one more example. Suppose if I take a number 27.24 base 10, that's a decimal number, and convert it to binary, that is base 2. So first let us do the integral part. In the integral part we have 27, simply divided by 2. 2 13s are 26, remainder 1. 2 6s are 12, remainder 1. 2 3s are 6, remainder 0. Then 2 1s are 2, remainder 1. 2 0s are 0, remainder 1. That is bottom to top. Coming to the fractional part. In the fractional part we have 0.24. 0.24 into 2, that is 0.48, and 0 will be out. Then 0.48 into 2, 0.96, in that 0 out. Then 0.96 into 2, that will be 1.92. In this we will be taking out the 1. Remainder is 0.92, that you can place down. Then 0.92 into 2, 1.84. Integral part is 1, that is out. Then again 0.84 into 2, that is going to be 1.68, 1 out, and we can stop after 5 steps. Remember, stopping after 5 steps means you are basically approximating the value. So if you convert it back to decimal, same value will not come, may not come. Okay. But if you go ahead and go further, then you may get the correct result. So it will take more places in the fractional part in the steps going ahead. But we can stop after 5 steps according to ICSE rules. So the final answer is 11011, that is for the integral part, 0.00111 base 2. Now the next conversion that I will show you, that is binary to decimal, which is obviously the opposite conversion of decimal to binary. So it is important that you know all the powers of 2, especially up to 2 to the power 6. If you know, that will help you. You may write it down also in the rough. 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8, 2 to the power 4 is 16, 2 to the power 5 is 32, 2 to the power 6 is 64, 2 to the power 7 is 128. I think that much will be fine. So let's take a question. Suppose the number is 10101 base 2 to base 10. Okay, that is binary to decimal. So take the number 10101, put power values 0, 1, 2, 3, 4 like that. Then we go ahead. So the digit which is at the base, you can call it bit also. In binary, digits are called bit. Okay, so take the bit into 2 to the power value whatever is there. So 1 into 2 to the power 4 plus, that is 0 into 2 to the power 3 plus, that is 1 into 2 to the power 2 plus, that is 0 into 2 to the power 1 plus, that is 1 into 2 to the power 0. Finally going ahead, 2 to the power 4 is 16, 0 into 2 to the power 3 will be 0, 2 to the power 2 will be 4, 0 into 2 to the power 1, that's 0, 2 to the power 0 is 1, so 1 into 1 is 1, and finally if you add it up, it's coming 21. So 21 base 10. Now let's take an example where we have a real binary number, the one which is having integral and fractional part. So for the fractional part, you need to know the values of negative powers of 2. So 2 to the power minus 1 is actually 1 by 2 to the power 1, which is 1 by 2, and 1 by 2 means 0.5. 2 to the power minus 2 is actually 1 by 2 square, which is 1 by 4, and 1 by 4 is 0.25. Similarly, 2 to the power minus 3 is 1 by 2 cube. 2 cube is 8, so that is 1 by 8, which is 0.125. Similarly, 2 to the power minus 4 is 1 by 2 to the power 4, which is 1 by 16, and 1 by 16 is 0.0625. So if you remember these converted values, then it will be easy for you to calculate. So let us take an example here. Suppose I say the number is 1101.011 base 2, that is binary, converted to base 10, that is decimal. So note down the question once again. You can solve the entire number together, unlike when you are converting decimal to binary, where you do the integral and fractional part separately, because the process is not same. In integral you are dividing, and in the fractional you are multiplying, but here it can be done together. Okay, so put power values 0, 1, 2, 3 in the integral part, and for the fractional the power will be minus. Okay, so minus 1, minus 2, minus 3, minus 4, so on. Then expand the line just like before. 1 into 2 to the power 3 plus 1 into 2 square, or you say 2 to the power 2, 0 into 2 to the power 1 plus 1 into 2 to the power 0 plus 0 into 2 to the power minus 1 plus 1 into 2 to the power minus 2 plus 1 into 2 to the power minus 3. Okay, so 2 to the power 3, this term is going to be 8, 2 to the power 2, this term is going to be 4, next term is multiplied with 0, so 0, next term is 2 to the power 0, that is 1, next term is 0 into 2 to the power minus 1, that is 0, and 2 to the power minus 2, this term, like I have told you here, is going to become 0.25. Similarly, 2 to the power minus 3, this term, it will become 0.125. Now you can add it up. 8 plus 4, 12, 12 plus 1, 13. So 13 in the integral. 0.25 plus 0.125, that is going to be 0.375. So this is the converted form of this number in decimal. The next conversion which I will show you, that is decimal to octal, and after that octal to decimal. Whenever you are converting decimal to any base, you have to divide by that base value. If you are going decimal to binary, which I was showing you before, then you had to divide by 2. Similarly, you are going decimal to octal. Octal is which base? It's base 8, correct? So when you are going decimal to octal, then you have to divide the number by 8. Similarly, if you were to go from decimal to hexadecimal, which is base 16, then you have to divide by 16. Just to remember this rule, it will help you to convert decimal to all the remaining 3 bases. Okay. Now let's see how it goes. So divide 70 by 8. Find the nearest multiple. 8 8s are 64, right? Nearest it's that only. So 70 minus 64, if you do, remainder is 6. Again, 8 1s are 8, remainder will be 0. Then 8 0s are 0, remainder is 1. Bottom to top, if you write the answer, that is 106 base 8. Let's take one more example. Suppose the number is 535. Okay, 535 base 10 to base 8. So same logic, divide 535 by 8, correct? Because we are going into base 8. So when you do that, divide by 8. 8 4s are 32, 8 5s are 40, 8 6s are 48. That is the closest. You have to do like that. 8 6 are 48. So 53 minus 48 will be 5. 5 and a 5, 55. So again 8 6 are 48. 55 minus 48 is going to be 7. Okay. So how I did, I repeat it once again. 8 6 are 48. 53 minus 48, if you do, that is going to be 5. 5 and this last 5 is 55. 55 nearest is, I think, 48. 8 6 are 48. So 55 minus 48, if you do, that is 7. Again, 8 9s are 72. 8 8 is 64. Nearest is 8. 8 8s are 64. 66 minus 64 is 2. Again, 8 1s are 8. Remainder is 0. Again, 8 zeros are 0. Remainder 1. Bottom to top, the answer is 1027 base 8. Now let's see the conversion from octal to decimal. Octal to decimal. Okay. So here also you need to know power of 8. Just like in binary to decimal you had to know the power of 2. Here you have to know the power of 8. So 8 to the power 0 is 1. 8 to the power 1 is 8. 8 to the power 2, that is 8 square, is 64. 8 to the power 3, if you do, that is going to be 512. This much if you know, that is fine. Okay. So let's take a question. Suppose the number is 72, that is 72 base 8 to base 10. So 72 base 8, put power value 0 1 just like before, and it is now 7 into 8 to the power 1. Understanding, when we are doing from binary to decimal, it was going like whatever digit into 2 to the power value, whatever it was. Now it's 8 to the power value. Okay. So 7 into 8 to the power 1 plus 2 into 8 to the power 0, like that. Okay. 7 8s are 56. 8 to the power 0 is 1. 2 into 1 2. Adding up, you get 58 base 10. Let's see one more question. Suppose the number is 123, that is 123 base 8 to base 10. Same logic, 123 base 8, put power value 0 1 2. So how it will be? 1 into 8 square plus 2 into 8 to the power 1 plus 3 into 8 to the power 0. So 8 square is 64. 1 into 64 is same. 8 into 2 will be 16. and 8 to the power 0 is 1, 1 into 3 is 3. If you add it up, that is 6 plus 4, 10 plus 3, 13, carry 1, 6 plus 1, 7 and 8. That is 83 base 10. Now we will see decimal to hexadecimal conversion. Decimal to hexadecimal. For hexadecimal, you will need to remember the code values which I told you before. So A is 10, B is 11, C is 12, D is 13, E is 14 and F is 15. So let's see decimal to hexadecimal. Here we will be dividing by 16. Suppose the number is 245. 245 base 10, that is decimal, to base 16, that is hexadecimal. So we will have to divide by 16. 245 divided by 16. So 16 ones are 16, 24 minus 16 will be 8. 8 and a 5 is 85. So 16 5s are 80. 85 minus 80 is 5. Again see, 16 ones are 16, 24 minus 16 will be 8. 8 and a 5 is 85. So 16 5s are 80. 85 minus 80 if you do, remainder is 5. Now you cannot divide 15 by 16. So simply write 16, zeros are 0, remainder 15. Bottom to up, 15 will be written as F and 5 will be written. So F5 base 16. Let's see one more question. Suppose if I take the number 982 base 10 to base 16, that is decimal to hexadecimal. So 982, draw the line, divide by 16. So 16 8s are, it is crossing 98, 16 6s are 96, correct? Okay, 16 6s are 96, 98 minus 96 will be 2, 2 and a 2, 22, 16 1s are 16, 22 minus 16 will be remainder 6. Again 16 4s are 64, not possible, 16 3s are 48. So 61 minus 48 if you do, that is going to be what? 13. So 13 is the remainder. Now 16 zeros are 0, remainder 3. Bottom to top, that is coming up as 3. 13 will be written as D and 6. 3D6 base 16. Now we will see hexadecimal to decimal conversion. For hexadecimal to decimal conversion, you need to know the power of 16s. So basic power 0, 1, 2 is fine if you know that much. 16 to the power 0 is 1. 16 to the power 1 is 16. 16 square, that is 256. That much only will keep. Okay. So let's take the first question. Suppose the number is AB base 16. Now since it is hexadecimal, so A, B, C, D, E, F letters will be there. So AB base 16, okay, power value 0, 1, A will be written as 10. So 10 into 16 to the power 1 plus B will be written as 11. So 11 into 16 to the power 0. Now 16 to the power 1 is 16, 16 into 10 is 160 and 11 into 16 to the power 0, 16 to the power 0 is 1, 1 into 11 is 11. If you add it up, it's 171 base 10. Okay. Let's take one more example. Suppose it is A95, that is A95 base 16 to base 10. Okay, so write down A95, power values you can give 0, 1, 2. A will be written as 10, so 10 into 16 square plus 9 into 16 to the power 1 plus 5 into 16 to the power 0, correct? 16 square is 256, into 10 will be 2560 plus 16 into 9 if you do, that is going to be 144, correct? Then 16 to the power 0 is 1, 1 into 5 is 5. Now if you add it up, 5 plus 4 9, 6 plus 4 10, carry 1, 1 plus 5 6 plus 1 7, so 2709 base 10. Now we will see binary addition, and after that finally we will see binary subtraction. Let's start with binary addition. First I will tell you the rules for binary addition. So the rules are as follows. 0 plus 0 if you do, the sum will be 0 and there will be no carry. 0 plus 1 if you do, the sum will be 1, again no carry. 1 plus 0 if you do, that will be 1, again no carry. 1 plus 1 if you do, then it is 0 and there will be a carry of 1. Similarly, 1 plus 1 plus 1 if you do, that will be a 1 with a carry 1. Okay. So let us begin with a question. Suppose we are adding 1 1 0 1 0 1 with the number 1 1 1 1 0 1. Okay. Let's write down the numbers like this. Okay. Plus, and let's follow the rules. 1 plus 1 0, the carry will go here. 1 plus 0 is 1. Again 1 plus 1 is 0, the carry will go over here. 1 plus 1 is again 0, the carry will go over here. 1 plus 1 plus 1 will be 1 with a carry over here. 1 plus 1 plus 1 will be 1 with a carry over here, and this last carry will come down. So this is your answer. Okay, let's see one more question. Let's write it directly this time. 1 1 0 1 0 1 1 1 1 and 1 1 1 0 1 0 1 0 plus 1 plus 0 is 1. 1 plus 1 will be 0 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 plus 1 is 1 with a carry 1. 1 plus 0 is 1, no carry. 1 plus 1 is 0 with a carry 1. 1 plus 1 is 0 with a carry 1. 1 plus 1 plus 1 is 1 with a carry 1. 1 plus 1 is 0 with a carry 1, and that last carry 1 will come down. So this is your answer. Now finally, let us see binary subtraction. So the rules for binary subtraction are as follows. 0 minus 0 is 0 and there is no borrow. 1 minus 1 is 0, again there is no borrow. 1 minus 0 is 1, again there is no borrow. But when you do 0 minus 1, this is the case where it is 1 with a borrow 1. Now what's the difference here? In binary addition we have carry. Carry means the total, the extra value goes to the next column towards the left side. Okay. And borrow means you are bringing from the column from the left side to the right side. Okay. So in borrow means we are bringing. Let's take a question. Suppose the number is 101010 and we are subtracting from it 1111. Okay, minus. So 0 minus 1, right? That is 1 with a borrow 1. Now how to borrow? Basically this 1 which is on the left side will become 0. Okay, we have borrowed from there. Now again 0 minus 1, it is a borrow. So we will write 1 here. And how to borrow? See, this is already 0. So we borrow from the first one which is on the left side. And if there exists any middle 0, that will be 1. Converted to 1. Okay. Now 1 minus 1, 0. Again 0 minus 1 we have to borrow. So look for the first one, make it 0. Any middle 0 will become 1. Okay. So this 1 will come down. That is your answer. Let's see one more question. 1 000 0 1 1 1 00 and subtracting from it times 1 0 1 minus 0 minus 1 we have to borrow. So borrow from the first one which is available, make the middle 0 1 if there is any middle 0. Then 1 minus 0 is 1, 0 minus 1 again we have to borrow, make this 1 0 and borrow from there. Again 0 minus 1 we have to borrow, so make this 1 0 and borrow from there. 0 minus 1 we have to borrow, but these all are zeros, so look for the first one, make it 0, all the middle zeros will become 1 and 1 has been borrowed. 1 down, that's your answer. Let's see one more question. 1 minus 1 0, 1 minus 0 is 1, 0 minus 1 we have to borrow. So borrow from the first one which is there, make all middle zeros 1. Okay, so 1 has been borrowed, then 1 minus 1 is 0, 1 minus 1 is 0, again 0 minus 1 we have to borrow. So borrow from the 1 and make all middle zeros 1. So 1 has been borrowed. Now 1 minus 1 is 0, and these two ones will directly come down because there is nothing to subtract. So thank you everyone for watching this video. More conversions will be explained in another video. Please look at the playlist of class 7. I have already uploaded many videos on the topic number system.